Hey, it's Joe, and welcome to another episode of the Test Guild Performance and Site Reliability Podcast. Today, we'll be talking with Stefano all about optimizing configurations of K8 and some really cool technology that they just announced with their company. Really excited about this. But before we get into it, if you don't know, Stefano is obsessed with performance optimization and is the CTO at Akamas. With more than 15 years of experience in the performance industry, he's worked on multiple projects, both national and international enterprises. He's presented at a ton of different events like SRECon, I think CMG, Performance Summit, the PAC, and I think he's going to be speaking at KubeCon coming up in a few weeks, which I'm sure we'll talk about. In 2015, he won the CMG Best Paper for contributing to capacity planning and performance optimization of Java applications. And in 2017, he shipped one of the first in the market Kubernetes capacity optimization solutions. So really excited to have him on the show. If you have anything to do with SRE, anything to do with Kubernetes, you don't want to miss it. Check it out. Hey, Stefano, welcome back to the Guild.
Hi, Joe. Thanks a lot for having me today. I'm really excited.
Awesome. Great to have you. Like I said, it sounds like you're doing a lot of great work at Akamas. So I'm excited to find out more about that. Before we do, is there anything I missed in your bio that you want the Guild to know more about?
Well, no, I guess it was great. So thanks a lot for summarizing that.
Sweet. So last time we spoke, I think it was last year, episode 81, it's almost been a year. I think it was in November. So, I've been seeing the shift from performance to SRE. And I don't know if that's something you've been seeing as well. I think in the pre-show, you mentioned something like maybe Akamas is maybe helping roll out more features to help SRE. Is that a direction you've been seeing more and more of?
Yeah, exactly. So actually, what we have been working on lately is the launch of new capabilities on the product, which is the 3.0 version of Akamas, which brings some major innovations around those topics. So for those who are familiar with Akamas, up to now, basically, the way we worked was to actually use AI to help mainly performance engineers to automate the tuning of the configuration of their application and infrastructure, things like JVM configuration, database configs, or Kubernetes resource settings, etc., mainly in pre-prod environments, so leveraging load test and tuning, automating the tuning of the configuration there. So mainly focus on performance engineers. So before the application was released to production or when a new business event might arise, etc. So that's what actually we help performance engineers do before the 3.0. And now with the 3.0, we are actually very excited because we bring major innovation into the platform, which is the ability to help optimize applications directly in productions. So that's kind of a new shift for the product, and that is actually, as you were mentioning, more geared toward SREs, so people that actually are interested in taking care of reliability, cost efficiency, performance of application running in production.
Nice. So is this a shift or is it just added benefit? So you still service performance engineers, but you have more features now to help SRE as well?
Yeah, great question, Joe. Actually, Akamas 3.0 becomes a platform. So it's a unique product. It's a unique platform that helps you basically address both scenarios. So that's the performance optimization in the performance engineering kind of development and pre-production staging environments still makes a lot of sense if you think about the DevOps trend. So being able to, for example, make sure configuration are great to sustain higher level of load that we are expecting. So something that we still don't see in production today. Or for example, addressing even chaos scenarios, chaos engineering scenarios like, for example, how do I identify the best configuration for my application that maximize reliability under certain failure scenarios? So there are still a whole lot of interesting use cases for which you might want to use Akamas in our pre-prod environments. We are actually adding a kind of new part of the product that lets you do the next step. So once you have launched your application in production, typically you have new needs to actually make sure it's optimized based on the new traffic, based on the actual way that users use the platform that might be different with respect to what we have designed in load test scenarios, or even keeping track of the changes that happen to the application, to the infrastructure in production. So it's an addition, and Akamas with the 3.0 becomes a holistic actually platform that can address both scenarios.
So this might be completely off the wall and incorrect, but is the shift because it's pre-production not as relevant as it once was? With cloud native and using all services in production, you really can never get the real performance or real optimization that you could in pre-production. Is that one of the reasons for this pivot? I'm just off base here.
Yeah, that's a great topic. I see. Actually, thinking about what we see on the market, we certainly see a shift towards actually moving directly in production. So doing much more experimentation in production as part of actually the DevOps culture of kind of shipping small increments of code even to the production and being able to roll out quickly, being able to test what would be the best product even for the user. So it's a kind of mindset shift that we are seeing, and that facilitate of course, doing those kind of optimization directly in production also, it's great for even for our use cases. But actually, for other companies, we see that they are actually incrementing their investments on performance testing. So I guess it depends a lot on the culture, on the actual business needs. We see kind of the two trends. So some people's organizations are kind of not investing anymore on performance engineering because they see the complexity, they see the skills that are required, the investments, and they're moving towards a more kind of agile way to test things in production. But the other kind of company, like for example, financial company, we see that they are actually investing more in a way, making sure reliability is there before shipping to production in order to avoid incidents once they have launched.
Great. So what's the benefits of then testing in production, basically?
Yeah. Actually, the thing is that when actually SREs look at an application in production, they typically have different kind of use cases, different kind of business needs. So one thing that we see a lot is that being able to optimize the cost. So that's for sure one of the biggest drivers. So we see that in the cloud native space, much of the responsibility for optimizing the cost relies on application teams, because at the end of the day, the cost of a Kubernetes cluster is dependent mainly on the way the application is configured. So how big are those containers, those pods powering our applications? So they struggle to do that. So that's a matter of being able to help teams reduce costs while not impacting performance, which is the other kind of side of the coin where teams are struggling, not having bad performance or even reliability. So that's kind of the other benefit, because again, due to the kind of tricky way that Kubernetes manages resources, we find that still many teams are struggling with that. So they risk of actually having production incidents, which actually can do a lot of scary things like reputational damage, etc., due to the way that the complexity of the environments of the stack, and that is creating lots of issues. So we see those are the benefits that drive. And the other thing is that, of course, there's a kind of skill shortage in the industry. So it's not easy to find people that are able to do this kind of work, and it still takes a lot of time, even for them. So the idea is that, of course, let's provide a smart system that can help those guys in making better decisions in quite drastically less time, basically.
So I think last time we spoke, maybe it was you, maybe it was someone else. A lot of the issues we saw were due to configurations of Kubernetes. So how does this work now in live? Is it all automated? And like you mentioned, there's a skill shortage. So are you trying to do all the heavy lifting? How does that work?
Yeah, that's great. So the way we work with, especially in the live optimization. So when we optimize in production, is basically we try to address the whole problem. So actually, Akamas first of all observe how the application is working in production. While we do that, we observe basically the infrastructure usage, but we also observe the traffic, the patterns, the response time. So we observe also application metric, and then Akamas basically is able to recognize the patterns of workloads. So it's able to understand if there are peaks, if there are valleys, etc., in order to actually understand how the application is behaving. And then Akamas, based on the AI models that we have built, actually start providing recommendations. So if you think about, for example, how we work in pre-prod environments, so the whole optimization cycle was completely automated in pre-prod environments. So basically, no people had to stare at the screen and see the changes, because actually the whole process could be automated. When we move to production, requirements change a little bit, meaning that people want to have control. So once Akamas identify the next configuration to try, it doesn't simply automatically change the application as they work in production, but now Akamas recommend a change to the user. So the user will be able to actually review the changes. For example, I want to change the size, the CPU limits and memory limits for this Kubernetes pod. I want to change the JVM parameters, like changing the garbage collection or the heap size. So people, as a result, want to have control, want to understand what will be pushed to production. So that's a kind of human-in-the-loop approach that is actually accepted by the market because they want to have this level of control. Next step is actually we need to roll out the changes to production, and that completes our optimization cycle. And that is, again, done typically integrating with DevOps pipelines. So typically, people, again, don't want any tool to change their application as they work in production kind of randomly without control. So what we do is typically we integrate with DevOps processes that customer have. This means typically, for example, pushing a configuration to a repository. So not changing the actual cluster, but pushing the new config on the repository where the DevOps team, for example, has the chance to, again, review and merge the request into the repository, and then typically a pipeline, Jenkins pipeline, for example, will actually roll out the change to production. So that's how it works.
Awesome. Yeah, I'm not sure if you're familiar with visual validation. A lot of times it does a baseline, and then it sees a difference, and then it asks the user, do you want to make this change based on this difference? Is this the same kind of approach? Does it just prompt you like, hey, we noticed blah, blah, blah. Do you agree? If so, do you accept these changes?
Yeah, exactly. So we provide the parameters. So our recommendation is, at the end of the day, is a change to the configuration. So we let the user see what is the current configuration, and then what is the next that is actually suggested by Akamas. So you can actually see what are the changes. So you can kind of familiarize with what we are going to change. By the way, users also have the ability to revise. So let's say that, I don't know, you want to skip some particular change or change the values of the parameters, so they are allowed to do so. And also in our UI, we also present, and I think that is important also in terms of explainability of what the AI is providing. We also present analysis. So the users can actually, right in our product, actually see how the application is performing. Am I slowing down? So perhaps a change is a kind of direct action because the application is slowing down. So we want to increase the CPU limits that we assign to the bot, for example, in response to a performance degradation, something like that. So that's kind of explainability capability that we provide into the platform, which I think are key for people to accept those changes.
Nice. Now, as the holiday season rolls in, Black Friday, will this help you scale up if you're having issues? And if so, does it say, hey, we can scale up to blah, 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 but there's going to be this cost associated with it? Does it give you that type of data?
Well, yes. So what we do typically is to right size the container. So, for example, selecting the proper CPU and memory limits for your containers, we can also act on the auto-scaling parameters. So that's kind of another use case where typically people already have built-in autoscalers from Kubernetes, like the horizontal pod autoscaler. So with Akamas, we help actually optimizing the horizontal pod autoscaler threshold, for example, to make sure that your overall goals are met, like let's find out the best configuration that keeps cost at a minimum, but still provide the required level of performance and reliability that I'm expecting.
Because you are focusing on live production, I think you mentioned SRE, but you also mentioned, I think, chaos engineering. Are there any features that help you with chaos engineering? Can you do like little segments to see what happens with an experiment? And if it works, give some insight. Hey, that worked. Maybe you should push that to your configuration going forward or anything like that? Yeah.
So somewhat. So on the chaos engineering, we typically work. We find people today at least prefer to start. It's kind of a journey, So typically people prefer to start in a pre-prod environments. Of course, we know that the holy grail would be doing things in production, but the way we see is that people are starting to actually adopt chaos engineering in pre-prod. So that's kind of one scenario that we see. So leveraging load tests, because in the end of the day, you need to reproduce things in pre-prod environments. While working on production, one practice that we see a lot is using canary releases. So, for example, when, let's say, the Akamas recommend a change, the question is, where do we apply that change? So sometimes we apply the chain to just a small portion of the pods that are powering, for example, an online front end for an e-commerce website. And then you can also observe how this subset or your canary or just a subset of the pods will perform, and then start actually comparing against the main control group in a way. So that also kind of another way to actually try out different settings directly in production. Of course, you will need to be much more safe, because actually in a pre-prod environment you are allowed to actually do anything you want, change any parameter, etc. In a prod environment, you need to be more careful, and that then brings to a whole lot of safety capability that we have to include into our platform to make sure that actually the recommendations are good for production and they are not causing any kind of adverse effect.
Very nice. Because it is using AI and machine learning, if you're using the same application over time, does your technology get better with better insights, or does it get smarter over time if it gets a large data set?
Yeah, that's a great question. So I guess that's super great, because actually that's the core of AI. So we see, by the way, a lot of marketing around lots of solutions that use AI to optimize applications. So one distinctive factor of real AI is that it's a learning piece. So as you said, it's exactly that. So the fact that we have seen different workloads, we can see what configuration works best with respect to the different workloads, and actually Akamas actually learn. So it will identify that for this particular microservice, for example, this specific garbage collection for the JVM works best. So they may be contrary to another microservice which prefer, another setting of the JVM or the containers. So this learning is key, because actually AI can adapt to the specific microservice and make sure that we can extract the cost efficiency for each application by learning how to tune each single application. So this is very different from other approaches that just use thresholds. Like if you are above 80%, just add more CPUs. That is a much simpler approach where no learning is actually there.
How much of autopilot can you put this on over time? Say like you've been running it for a year, it's been working, you've been accepting things, and you're like, look, I get the insights, but I don't have time for this sometimes. Just check this off, I accept it, do it automatically. Is that an option?
Yeah, that's a great question, Joe. Actually, we have two modes in the kind of production optimization. So the manual approval and the fully automated. So manual approval is basically the process that I have just described. So basically a human will get a recommendation to actually review and then apply to production according to the OS processes. Actually, we envision as the customer gets trust into the recommendation, we also already have the ability to put the kind of fully autonomous mode, where actually Akamas will be able to actually skip this manual validation process and just, for example, either apply the changes directly to your Kubernetes cluster, or actually, again, leveraging your processes, changing the configuration of the microservices, again, in line with the infrastructure as code or everything as code approach, and then trigger a pipeline completely automatically. So we also envision kind of gradual. That's kind of the future state where customer can reach those kind of maturity. We also envision some, gradual path towards that. So perhaps some parameters might be changed live, even without restarts of the application. So they might be kind of automatically configured by Akamas without any prior approval. So you have those capabilities. So you have also the ability to define ranges and increments. So for example, you can say, okay, I want to change the parameter within those ranges so that I'm safe that AI won't identify big values for very small values for my CPUs that might be risky. So you get those kind of safety policies that you can define within the platform, and that's I think that that's one of the main features, main differentiator that we have, because people want to have those kind of control and in order to trust a solution like that.
Absolutely. So I know in performance, since I've been involved all these years, it's always been like either throw more hardware at it or optimize your application to be more performant. And I guess as more people go cloud native, they start using Kubernetes. I assume this isn't a magic option. Like if your application is not optimized to be performant, it's not like is this going to be fix all that, or do you have any lessons learned on like people using Kubernetes and Java optimization challenges you've seen with your clients or customers?
Yeah. Actually, in fact, we have been working on, especially with many customers around Kubernetes lately, and especially Java is still one of the most popular languages for modern microservices, leveraging framework like Spring Boot, etc. So we have learned quite a bit of interesting lessons learned there. And I like your pillars, as we call them. So the fact that we typically have dealt with those kind of problems by throwing hardware or by fixing the code. Actually, there's this middle kind of layer, which is the configurations. So those configurations, we are finding that especially not simply the configuration at the container level, but at the runtime level. So at the end of the day, what runs within a container or a Kubernetes pod is actually the runtime, like the JVM or Golang. And they are ultimately actually responsible for driving, for example, resource usage. So the amount of memory your Kubernetes application or the amount of CPU they will be using. Of course, that's dependent on the actual application, the actual business logic and the code. But actually, there's a non-trivial part, which is actually the responsibility of how the JVM, for example, manage memory, how the JVM manage the CPU, so how the garbage collector is working. So what we have found out is that, for example, one of the biggest issues is that people is suffering reliability problems in Kubernetes application. So the dreaded out-of-memory kills. So Kubernetes is very different when it comes to managing memory with respect to, operating system like we have worked in the past. So there's no swapping, there's no slowdown. So Kubernetes suddenly kills your pod, your container, as the moment that you reach the level of memory limits that you have configured. So a lot of teams are struggling with that. And the issue there is that, again, the way that the runtime works is key. So, for example, what we have found out is that there are many organizations that configure the JVM with the heap size very close to the memory limit. So the problem is that the JVM, for example, allocate extra memory beside the heap size, and that is very easily triggering out-of-memory errors and all of a sudden bringing services down in production. So that's the problem is that it's a hard problem because there are no well-defined configuration options for the JVM, for example, to actually keep the whole footprint within the limit. So people do a lot of trying and error there. So the key lesson learned is that you need to configure properly, also not just the CPU and the memory setting at the container level, but also review what is the configuration of your runtime, especially the JVM. But we are seeing similar and interesting in a way, development also on the Golang runtime, which is kind of following a similar path. So it's not just the JVM itself, but it's pretty much the same. Is happening to pretty much any garbage collected language, which includes also .NET, for example, or Golang, or even JS. So that's kind of the common thing that we are seeing.
Right. So as is for those issues and with live production, then does it help you? Because it actually adds costs, I guess, if you don't have things sized right. Does it help you with pod resizing and node right sizing also?
Yeah, we work at the basically what we call application aware. We means working at the different layers of the stack. So we work at the pod level. So basically being able to right size the containers, the pods, the containers that run within the pod. So CPU and memory, request and limits. But also we have actually identified the best settings for the runtime that run within, so like the JVM, etc. So that's one part. The other part is that that is the differentiator we have is that when doing those kind of optimization, we find people are struggling because actually due to the way that, again, Kubernetes memory management or CPU management works, you can have lots of side effects if you don't properly size the configurations. So, for example, another problem that typically people run into is what is called CPU throttling. So you will get slowed down by the Kubernetes resource management mechanism if you are not properly putting your CPU limits in place. So the answer that we have is that we identify that the only way to actually be safe on one side regarding reliability and also ensuring performance while reducing the cost is being able to actually drive the optimization based on the actual application response time. So that is key because actually there are lots of solutions that simply look at the infrastructure, like I'm using 10% of my CPU usage. Let's bring down the CPUs because I'm using very little. But then you run the risk of introducing this kind of adverse throttling, etc., which are very counterintuitive. We find that people are having a hard time managing with that. So the way that we tackle this problem is we actually see the workload. We gather metrics from observability tools like application response time and the throughput, the patterns, etc., to being able really to recommend configuration that can reduce costs, but minimize the risk of introducing slowdown or reliability issues.
It's a good point. Observability has been a big trend the past few years, and it sounds like that's something you're highly integrated with as well.
Yeah, exactly. Because again, many solutions just simply we try to solve the problem at the infrastructure layer. So you simply need in a way monitoring or observability tools just looking at the infrastructure. But we of course we need lots of metrics also from the whole stack in order to be able to drive smarter recommendation. And again, our approach is not having any agent but rely on the integration. So we have native integration, for example, with Prometheus, which is, I guess, one of the most common stack in open source stack that we find for Kubernetes settings, but also Dynatrace. We find we are very much integrated with them because, again, it's one of the most common tools, commercial tools that we find on the market.
Absolutely. So it sounds cool, but I'm sure people would love to see this, see a demo, see it in action. You did mention, I think, in the pre-show something about KubeCon. So what is KubeCon? If people want to see this in action, maybe give us a little more information. I believe you're going to be there.
Yeah, exactly. So that's great points, Joe. We will be having a booth there. So KubeCon is basically the leading CNCF, Cloud Native Computing Foundation conference around the Kubernetes ecosystem today. So really, I think it's one of the biggest conferences that we have today in IT. So next edition in North America will be actually in 2 weeks' time in Detroit. So I'm very excited to be there. So we have a booth with our team. So just hang out, come to the conference if you can do that, and we will be having live demos. So if you want to see actually the live product in action, I guess that would be awesome to chat with the attendees.
Awesome. And I believe Scott Moore is going to be there. So I think everyone that listens to this knows Scott Moore. So he's always a hoot. He might be in his Elvis outfit. So you definitely should check that out.
Yeah, exactly. So Scott will be with us at the KubeCon. So very excited also to actually hang out with him, and will help us actually driving the demos and talk with the customer, etc. So I guess that we're gonna have a lot of fun.
All right, awesome. Okay, Stefano, before we go, is there one piece of actionable advice you can give to someone to help them with their performance, SRE, Kubernetes testing efforts? And what's the best way to find you, contact you, or learn more about Akamas?
Right. So we have a website, akamas.io. We have published several resources there, several blog posts around exactly those topics. So we have white papers that describe better in more detail how we work in production. So how do we optimize Kubernetes microservices with an application-aware approach, so people can download it, and that is it. So feel free to. I always love getting in touch with practitioners, so people are having those kind of issues, and you can also find me on Twitter and on LinkedIn.
Thanks again for your performance testing awesomeness. For links to everything of value we covered in this episode, head on over to testguild.com/P98. And while you're there, make sure to click on the Try Them Both Today link under the exclusive sponsors section to learn all about SmartBear's 2 awesome performance test tool solutions, Load Ninja and Load UI Pro. And if the show has helped you in any way, why not rate and review it in iTunes? Reviews really do matter in the rankings of the show, and I read each and every one of them. So that's it for this episode of the Test Guild Performance and Site Reliability Podcast. I'm Joe. My mission is to help you succeed with creating end-to-end, full-stack performance testing awesomeness. As always, test everything and keep the good. Cheers.
Thanks for listening to the Test Guild Performance and Site Reliability Podcast. Head on over to testguild.com for full show notes, amazing blog articles, and online testing conferences. Don't forget to subscribe to the Guild to continue your testing journey.